Hi ladies and gentlemen, in this part of section 2.4 we are going to talk about multiplication rule. In the previous part you learn about conditional probability, using the definition of conditional probability to calculate the probability of an event, and also using the principles of conditional probabilities to calculate the probability of an event by using frequency tables, probability tables, Venn diagram. But in this part we are going to talk about multiplication rule and using the multiplication rule to calculate the probability of an event, and also identifying conditional probabilities from a tree diagram. Here is your homework for this part, exercises 49, 51 and 55, and please look at examples 2.26 to 2.29 in section 2.4. But what is multiplication rule? In the previous part we talked about conditional probability and the conditional probability definition. You can see here that the probability of B given that A is equal to probability of A intersection B divided by probability A. So the probability of event B occurring, given that event A has occurred previously, is the probability of both A and B occurring divided by probability of A occurring. Now all of you know about cross multiplication method in mathematics. So from the definition of conditional probability, we have the probability of B given that A is equal to probability A intersection B divided by probability A. So by using cross multiplication, we have the probability of A and B both occurring is the product of probability A and probability B given that A. So the probability of both A and B occurring is the product of the probability of A and the probability of B given that A. This is multiplication rule. But when we are going to use a multiplication rule, one, when the probability of A and B both occurring is desired, and probability of A and the probability of B given that A is given or are given, and when the probability of A intersection B is desired and A and B happen one by one. It's the keyword. Okay, look at here. We have two events, A, B, and what's the meaning of one by one? It means first A and second B. So the probability of A and B both occurring is the probability of A, first A, A is the first one, and second B. So we have an information. Now we know that A has occurred previously. So we are going to use the conditional notation for showing the probability of B. So the probability of B, given that A has occurred previously. So B is the second one. So we have information. What is that information? A has occurred. So when we are going to use a multiplication rule, when A and B or the events happen by one by one, so the probability of A and B both occurring is the probability of A occurring multiplied by probability of B occurring, given that A has occurred previously. It means A has occurred before B. But what if we have more than two sets or two events? So the probability of A1 and A2 and A3 all occurring is the probability of first A occurring, second the probability of A2 occurring, given that A1 has occurred previously, then the probability of A3 occurring, given that A1 and A2 have occurred previously. So the probability of A1 and A2 and A3, if A1, A2 and A3 happen one by one, is the probability of A1 multiplied by probability of A2, given that A1 has already occurred, multiplied by probability A3, given that A1 and A2 have occurred before A3. Please note that it doesn't matter which one occurred at first. For example, we can write it as the probability of is the probability of, for example, first A3, then A2, given that A3 has occurred, multiply A1, given that A2 and A3 have occurred. Please note that in multiplication rule, the probability of A is called prior probability, or it's the additional information for probability for event B, or for calculating the probability of B. Noun before the time, so is the prior probability, and the probability of B, given that A is the posterior probability, it means the probability of B after updating with noun information about probability of A. So is the prior probability, and is the posterior probability, is the updated probability, because we already know that A has been occurred previously, and we have some additional information that by using this additional information we can update the probability of B. Now look at here. How we can use multiplication rule to calculate this probability, the probability of A and B both occurring, given that C has occurred previously. So what is the probability, what is the multiplication rule for A and B? The probability of A and B is the probability of A, the first one is A, multiplied by probability of B, given that A has occurred previously. Also, we can write it as this equation. Now we suppose B is the first one, so is the probability of B times probability of A, given that B has occurred previously. So it doesn't matter which one is the first one. But now we want to calculate the probability of A and B, given that C, by using multiplication rule. Now the probability of A and B given that C. So we already have an additional information. Okay, we should just follow the definition of multiplication rule by considering this additional information. So suppose B is the first one. So the probability of B given that C, we have an additional information about C. So the second one, so B is the first one, and the second one is A. Now we have information about B and C because we had an additional information about C, and from here is the first one and it's the second one. So now we have the information that B and C have occurred previously. So the probability of A and B given that C has occurred previously is the probability of B given that C has occurred previously multiplied by probability of A given that B and A have occurred previously. It means before A. So B is the first one, A is the second one, but we know that there is a C here from the past. So the probability of B given that C has occurred previously, and then the probability of A given that both B and C have occurred previously. Again, the first one is B, the second one is A, but there is a C from the past. So the first one, the probability of B given that C has occurred previously, and then the probability of A given that B and C have occurred previously. So you can see we could obtain this equation, and also you can see the proof here. If you have any question about the proof, you can send email or write in the discussion board.